Hi, I'm Mrs. Vandegrift. I am one of the beginning algebra teachers here at LCA. Every year we ask our students to do a summer math assignment. I know it's not everyone's favorite. However, it is so helpful to students and teachers for you to practice those skills. Math is kind of like a language. If you're not using it, you lose it. And by practicing them, we don't want you to forget these basic skills, because when you come to our class, we expect you to know how to do this so that we can teach you the higher level of math. These are skills that hopefully at some point you've mastered, and we really want you to just practice. It's like a brain workout to help your brain remember these skills. So, with that said, I am going to be walking you through the first half of your summer math. Note, if you have any questions at all, my email, you can find it. It's svandegrift. You can look at our website and find it. Please email me, and I would be happy to send a video, do anything to help you with your summer math. So, with that said, we're going to dive into the first part of your summer math. It starts off, there's 10 questions where you are you're simplifying fractions. And in this, we are expecting you to know how to reduce these fractions. And one of the things I like to say in my class is that by reducing these fractions, we're not changing the value or what that number represents. We're making it look simpler. For example, if I am 21 years old, I'm not, but let's say I'm 21. I could say I am 21 over 1. The simplest way to say I'm 21 would be to just write 21, but I could write 21 over 1. It's the same thing. I can write that I'm 42 over 2. That's also 21. It's not the simplest version, but it is also 21. I could also write that I am 21.00000. That is also 21. It just looks different. So math is needing to understand that we can play around with these numbers with the same number and it not change the value of that number, if that makes sense. So in simplifying these fractions, again, we're not changing. They're going to equal the same. So in this case, I know that 8 goes into both of these. So I divide by 8 over 8, reminding you it has to be the same number because that is like dividing it by 1. Going back to my example, if I'm 21, I could say divided by 1, it's still 21. So by dividing it by 1, it's still the same value. It's just going to look a little different. So 8 divided by 8 is 1. 16 divided by 8 is 2. So 8/16 is the same as 1/2. In this case over here, 30 over 48. Let's take this approach. Let's say, I don't know. They're both even. So let's try and divide them by 2. That's going to be 15. And that is going to be, let's see here, 2 goes into that twice, 4. Is that the simplest? I did reduce it, but can I reduce it more? I can reduce it more. What goes into 15 and 24? So while this is the reduced form, it is not the simplest. I can divide by 3. Oh, it's important to write the right number. 15 divided by 3 is 5. 24 divided by 3 is 8. And that would be your answer. So sometimes students just go one step, but if it asks for the simplest form, or to simplify to the most you can simplify it to, you have to make sure it's all the way reduced to this number. Okay? The next part that you see has to do with integers and positive and negative numbers. This is massively important that you know these rules and that you understand how to add and subtract, multiply and divide positive and negative numbers. Very, very, very important, because we won't be spending a lot of time on that. You are expected to know these things. We'll review, but we won't spend a long time on it. So this is something you're probably going to need to know. So if I'm adding or subtracting, negative and positive numbers, you need to make sure you look at the sign. Let's talk about adding first. If you're adding, if they're the same sign, you add them together. 2 plus 2 equals 4. Negative 2 plus negative 2 equals negative 4. They're the same sign. They keep the same sign. If they are different signs, what you do is you actually subtract the two. If we're adding, we actually subtract the two numbers and we give the sign to the digit that's the highest. Not the highest value, highest digit, the absolute value of that number, but I'm trying to use terms you know. So let's say negative 3 plus 2. They have different signs, therefore I subtract. 3 minus 2 is 1. But the 3 is the bigger digit than 2. 3 is the bigger digit than 2. 3 is a negative number, so we give this a negative. Does that make sense? I'm using very easy terms because I want you to see what I'm doing. Think of it this way. If I borrow $3 from mom, okay, you borrow this is real life math. If I borrow $3 from mom, but then dad gives me 2, do you think mom's going to want some of that money? Yeah, you're going to pay that debt. And then how much do you owe mom? You owe mom 1, okay? That's one way to look at it. Now, if you're subtracting integers, we do this thing where we have let's take 5 minus 3. You keep 5, you change this, and you change this. Keep, change. I do believe Miss Shack has an awesome phrase she uses, but I forget it. So keep, change. 5 keeps it's positive. The subtraction changes to positive, and the negative on this guy changes. So that is really saying 8. Now, playing around with these same numbers, if I have negative 5 minus 3, I'm going to keep, change. So now I have negative 5 plus negative 3, and that's negative 8. So you have to make sure you know these different rules with integers. This is not the same as multiplication. If I'm multiplying, I need to make sure you know this. Multiplying and adding and subtracting, not the same rule as far as the sign. If I'm multiplying or dividing, If it is the same number, positive times positive, it's going to give you a positive number. If it is negative times a negative, it is a positive number. If they are different signs, then it is a negative number. That is how multiplying or division works. So I can change that to be a division sign, and it's going to be the same rules. Okay? If they're the same, they're positive. If they're different, it's negative. And that's when you're looking at two numbers, not if there's three numbers. For example, let's look at some examples. If I have -2 times -2, that's going to be a +4 because they're both the same sign. If it is -2 times a +2, then that's a -4 because it's two different signs. But what happens if you have -2 times -2 times -2? It's all the same sign. Is it positive? No, because when we talk about the rules of these things, we're talking about two numbers being multiplied. So these two numbers are both negative. -2 times -2 is a +4, but now that +4 times a -2 gives you a -8. So it's important to look at these rules when talking about two numbers. When you're dealing with fractions and decimals, keep in mind you can't add or subtract numbers that don't have common denominators. You can't, fractions have to have a common denominator. Decimals, you have to line up the decimal. So if I have 5.1 minus 3.02, you have to line up the decimal. 5.1, 3.02. And I can add here, not changing the value, adding, I can add zeros forever. If it's a decimal, you can add as many zeros as you want at the end. I'm just going to add that one. Can't do that. That's going to be 802. So just making sure that you line up decimals, that you remember those integer rules. Okay? So it's also, if you see the word product, that means multiply. If you see the word quotient, we're dividing. All things that are important. So, I will do number 24. We have -1 minus negative, all negative. Subtracting, we're dealing with negative, okay? We're dealing with, this sign is about the same. So first I'm going to tackle my integer rules because we don't like subtracting. So I'm going to change that to keep, change, change. Keep, change, change. Okay. So now I don't need to have the positive sign there because when I tell you I'm 21, I don't say I'm 21 with a positive sign. You know it's positive. I didn't decline in years. It's a +21. That positive, you don't need it. So I took that away for this example. Okay? So now that I have this, I need to have a common denominator. So my common denominator is going to be 7. So now I'm going to have 7/7 plus 10/7. Now, remember when I said if they are the same sign, adding, you add them together and give the sign that they are. When they are not the same sign, you subtract them and give the sign to the larger digit. Ready? So in this case, I know that 7 is going to be my common denominator. 7 stays there. So now I'm really just looking at those two numbers. It's going to be a net, 10 and 7. What's 10 minus 7? 3. They're different signs, so I subtracted them. 10 minus 3 is 7. No, 7 minus 3. 10 minus 7 is 3. You're welcome. It's summer. What sign do I give 3/7? A positive sign, because that 7 is a smaller number than 10, and 10 is positive, so 3 is going to be a positive number. So that is an example of doing that. All right. Going to algebraic expressions. We've spent a lot of time with integer rules. You really, really need to make sure you know that coming into 8th grade. All right. Writing the algebraic expression, the sum of, if I'm looking at number 39, the sum of 9 and 6. If I am, it says write each algebraic expression. It's not asking you to solve. It's asking you to write the expression. That's like a math sentence. So that's saying the sum of 9 and 6. That's it. We know it's 15, but the algebraic expression would be this. This is the expression. So number 40, if you want to say 15, you can, but it says write the algebraic expression. All right, number 40, 13 decreased by x. 13 decreased by x. Decreased, we're subtracting, it's negative, blah, 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 blah. And the last portion of Miss V's review is order of operations. PEMDAS. There are still people out there in the world that do not know what PEMDAS means. Please excuse my dear Aunt Sally. Order of operations. Not knowing this rule is what gets people in trouble. You always want to do the parentheses first. An exponent might be this right here, if it's squared. Then you have multiplication and division, and you have addition and subtraction. Here is the biggest mistake everyone makes, even adults. If I'm on Facebook, I'll see this math problem and they always say 90% of people get this wrong. They do. They get it wrong because they do not know order of operations. So let's tackle that first. The big thing that you need to know is once you've done these two and then you have multiplying and dividing, you just go left to right. So let's say it's 5 divided by 1 times 2. Division looks like it's after multiplication, but if it's just multiplication and division, you just go straight through. 5 divided by 1 is 5, times 2 is 10. Now, if we had this, let's put those parentheses up. Then we do this first. 1 times 2 is 2. 5 divided by 2 is not 10. So this is why order of operations is so important. So you need to know these. All right. So we've review. You need to know your integer rules, and you need to know your order of operations. Like, I hope you're dreaming about it in your sleep. You may not, but I am. I'm hoping you dream about it in your sleep. All right, so if I look at number 48, I don't want to do just easy ones. I want to do some of the hard ones. 48, we have 5 minus 6 minus 12 divided by 4. In this case, we do the parentheses first. So I'm looking here. In the parenthesis, what is first? The division. So 12 divided by 4 is 3. So we have 5 minus 6 minus 3. 6 minus 3 is 3. 5 minus 3 equals 2. And that would be your answer. If I go to, I think you could do all those. You have your integer rules, your divisions. Let's do number 57. Has fractions in it. Don't be afraid of fractions. Don't be afraid of fractions. Don't let them fear. Don't get scared of them. 4, 1. Understanding them is probably, this is number 57. Oh, you can't even see the number. 57. Plus 1. When I have that 3 up there, that's cubed. And that 3 up there means I'm multiplying it 3 times. Not by 3, 3 times. So in PEMDAS, please, I have my parentheses, excuse exponents. So this right here means 1 1/3 times 1 1/3 times 1 1/3. 3 times. Now, I love improper numbers, improper fractions. I think they are fun. I like them. Improper, if I'm 21, I could say 42 over 2. That's improper. The number on top is bigger than 2. That is an improper fraction. To make these improper, I assume you know, 3 times 1 plus 1. So that's going to be 4/3 times 4/3 times 4/3. Fun. 4 times 4 is 16 times 4. 4 times 6, 24. I believe that is 64. 16, 4, that is 24, 2, 4, 6, 64. Okay, then 3 times 3 is 9. 9 times 3 is 21. Now that I have this, I need to go back and put it here. So I have 64 over 21. Now, I could simplify this. I could. I can make that improper. I could. Because this is improper, I might make this improper. There are multiple ways to add fractions together. So you do what makes you get the right answer. If you have a way that's different than what I'm about to do it. Miss Langford, Miss Shackelford, Miss Clark, whoever you've had, they might teach it a little differently. They might do it a little differently. And that's okay. We can still get the same answer and have the same strategy. I'm not going to teach you something that won't work. It just might be a different way than what you've learned before. So I'm going to try and simplify that. I believe 3 goes into both of these. 3 divided by 6 is 2. Oh, nope, 3 doesn't. Just kidding. I'm going to leave it. 6 times 4 is 24, 25. So that's 25 over 6 plus 64 over 21.